Yeah, preparation. Okay. So which yeah. So preparation we can do, not a problem. So you can also tell me what you know and what are the weak points. We can discuss that, right? And yeah, okay. So phenols, preparation of phenols. So how do you prepare phenol? The one method is by chlorobenzene. Okay. Or suppose if someone say you have to prepare it by benzene, you need to prepare chlorobenzene. So benzene to chlorobenzene, how will you make it? Yeah, Darshan. We can take Cl2 and FeCl3. Okay. And this is going to give us FeCl3 is a Lewis acid, or AlCl3 also you can take that also is a Lewis acid. So that is going to give you Cl plus. Cl minus will be taken away by FeCl3, and Cl plus will attack benzene and H plus will come out. So plus HCl, right? So this is chlorobenzene, and chlorobenzene to phenol. What is the method? Any method you know? What's the name of the method? So Darshan, what this? Yeah, it is hydrolysis. Yeah, but actually you need very high temperature, right? It is a kind of hydrolysis only, but you require very high temperature. So why chlorobenzene is less reactive? Tell me. Because chlorobenzene is less reactive. Actually, the benzene is having double bonds, right? So double bonds are because of the p orbitals. Okay, this is, yeah, resonance exactly, and the Cl is having the double bond character. So it is very difficult for the Cl to break apart. Yeah. So we need very high temperature so that the OH will have sufficient energy. It will come and get attached to the benzene ring. And because it is a nucleophile, so when it comes in, it will push away the pi electron. Okay. So this is the mechanism. If someone asks you, okay. But if someone asks you the product, you can directly write phenol. Okay, this is hydrolysis. And what's the name of this? But actually, because it is a basic medium, you need to write H plus also, because it will be O minus. Okay. So H plus will make that O minus as OH. So what's the name of this method? Yeah, Darshan. Yeah, it is Dawes process. Okay, clear. It is Dawes process. So it is used to prepare phenol from chlorobenzene. You need very high temperature. Okay, but if you have nitro group attached in ortho and para position, the reaction become easier and easier, right? So this is known as nucleophilic aromatic substitution. It is bimolecular. Because OH minus is a nucleophile. So no, it is not SN1 or SN2. SN1 or SN2 reaction happens on the normal carbon group, alkyl halides. Okay. Yeah, Darshan, right? Yeah, exam portion. Yeah, we can discuss all these points. You can go through it. Okay. And you can take the screenshot. Okay. So quickly we will go through all the phenol chapter. Yeah, PDF actually it is not possible to share from this. Okay. So you can just have the uh, screenshot. That will be same. You can make the PDF. Okay. And let me know if you have any problem. I will help you out. Okay. So this is chlorobenzene. And what will be the rate of bimolecular nucleophilic aromatic substitution? Where it will be faster? Rate of reaction, yeah, Na2 makes it more faster, yeah, because NO2, wherever the NO2 is, so there will be a plus charge, and a plus charge will make the attack of OH minus very easy. Okay, so because of that, it can attack very quickly, and the rate becomes faster. Yeah, exactly. So more and more NO2 you have, more is going to be the rate of this reaction, and the NO2 group need to be at the ortho or para position, then only it will be helpful. Suppose if we take the NO2 at meta position, that is not going to help much. Why? What's the reason? Because NO2, wherever the NO2 is, the plus charge will come at ortho and para positions, but we need NO2 such that it increases the plus charge on the carbon atom where the Cl is connected, so that the OH minus can come in and join itself to the benzene ring. Okay, so this is Dawes process, which is nucleophilic aromatic substitution on benzene. This is not SN1, this is not SN2, right? This is different molecule, different mechanism, and this is a mechanism which is the mechanism of nucleophilic substitution on benzene ring. Okay, that's why it is called nucleophilic aromatic substitution reaction. So I hope this is clear to you, right? Yeah. Okay. So the next one is the next one. If you look at it, is you can prepare phenol by cumene hydroperoxide method. So what do you mean by cumene? Yeah, cumene hydroperoxide method. So how do you? What is cumene actually? Yeah, Darshan. So cumene is actually isopropyl benzene. Okay, and you prepare phenol by this method. So what you do, you take benzene and you take propene. Okay, and the H plus will comes in and join and this propene group in a Markovnikov way. So H plus attaches itself to the carbon atom bearing more number of hydrogen, and it will be like this, and this will result H plus we have taken as H3PO4 as acid that act like a catalyst. Okay, so H plus will come in and join itself, and you will have a cation. This cation will get attracted toward benzene. It will go and attack on the benzene, and H plus will get removed. Okay, and this is electrophilic aromatic substitution, and you have isopropyl benzene. Okay, isopropyl benzene is known as cumene. That's the common name. Is it clear, Darshan? So if you prepare phenol by this method, then it is known as cumene hydroperoxide method. Is it clear? Okay. So this is carbon, and we have a hydrogen here also, Darshan. Okay. So what we do, we react it with oxygen. No, it's not ozonlysis. Ozonlysis is O3. This is reaction with oxygen, and this oxygen, this hydrogen is benzylic, being connected to the carbon which is uh, directly outside the benzene. So O2 is there. Okay, so what happens, this oxygen will get connected to the carbon, this H will break, and the oxygen will get come between the carbon and hydrogen. So you take heat or light. So this is like ozonlysis, but if you would have used O3, then it would have been known as ozonlysis. Okay, and that's why the name of the reaction is because of this only, right? The name of the reaction is because of this, and this is cumene hydroperoxide method. Okay, this is, look here, so this is peroxide linkage, that's why the name peroxide. Yeah, protonated water we will use after at this. Yes, so this group is isopropyl benzene. Okay, the isopropyl is there and the benzene is there and hydrogen on the one side. So Darshan, it is cumene hydroperoxide. Okay, this molecule is known as cumene hydroperoxide, and the name of the reaction is because of this only, cumene hydroperoxide. The name is because of this. So now you take H plus H2. Okay, now you do the hydrolysis. So this peroxide breaks, the OH breaks. Okay, because of the H plus, right? You actually heat it with concentrated H2SO4. You heat it with concentrated H2SO4, and because you heat it with concentrated H2SO4, the water will get removed. Okay, this OH will get removed. Okay, this one, and the phenol will get connected to oxygen. This is the shift. Okay, is it clear? Okay, and you have a plus charge here, right? And the water will come in and join again. This is the mechanism. I will just telling you to help you out. Actually, this you get, and from here you get the phenol. So you can directly write. You can directly write acetone and PHOH. Okay, this is the phenol. Okay, what you can do is this cumene hydroperoxide. I will tell you the trick. This is the cumene hydroperoxide. Okay, this is isopropyl and this is benzene. You take PHOH out of it. Okay, and the remaining portion which you get is acetone. Okay, so what you get phenol plus acetone. So there are questions many times asked, what is the byproduct for the preparation of phenol in cumene hydroperoxide method? It is acetone. Is it clear, Darshan? Yeah, you can use mic also, no problem. Okay, so this is very important method. The next method is by sulfonation. Preparation of phenol by sulfonation of benzene. Okay. Preparation of phenol by sulfonation of benzene. Okay, sulfonation of benzene. So benzene you take, and benzene you react it with concentrated H2SO4. Okay, and you get benzene sulfonic acid. This is the sulfonation of benzene ring. Okay, yeah, H2SO4. And now you heat it with NaOH, strongly with NaOH. And this is the same mechanism which we discussed, that bimolecular NAS in Dow's process. Okay, it is H2SO4. Okay, sulfuric acid, that will give benzene sulfonic acid. Benzene sulfonic acid, you heat it with NaOH, you get ONA. Okay, actually you get OH, but because it is a basic medium, so that H plus will be replaced by Na. So it is sodium phenoxide, and you take water, protonated water, that gives you OH. Okay, is it clear? Now HNO3 is for nitration. HNO3 H2SO4 you take, that is for nitration. But if you take H2SO4, that is for sulfonation. Okay, so I hope it is clear, Darshan. Yeah, so it is the preparation of phenol by sulfonation, right? So you prepare benzene sulfonic acid, and by sulfonation of benzene, and you take NaOH heat, the sulfonic acid group will be replaced by OH group. And because it is basic medium, so OH will become ONA, so you need the H plus H2 protonated water to get back to OH. Is it clear? Any doubts on this? And the one which you were talking about is actually the reaction uh, through disonium. By using disonium salt also you can prepare phenol from benzene. So tell me, how do you prepare phenol by using disonium? Yeah, Darshan. Right? Clear? Should I move down or up? So how do you prepare phenol by disonium? Yeah. So how do you prepare disonium salt? That you can tell me first. Yeah, Darshan. How can you prepare disonium salt? I hope you are noted it down. So yeah, okay, good. So first how do you prepare disonium from benzene? Disonium salt. Benzene disonium salt. Tell me. Yeah, NaNO2, but you need, first of all, you need nitrobenzene. So you do the nitration. Nitration, you take nitric acid and H2SO4. Okay. Actually, H2SO4 takes away the OH. Yeah. Yeah, from aniline you take NaNO2. Good. Yeah. So aniline from benzene, you need nitration. You will get the nitrobenzene. Nitrobenzene you need to reduce using 10 and HCl. Okay. Yeah. And now you take NaNO2 and HCl. Right? And what's the temperature which you take? You keep the temperature low so that the diazonium which forms doesn't break. Okay, so and it gives NO plus. Okay, NO plus actually get attached to NH2 and water get removed. And if water get removed, you have N triple bond N plus. Okay, this is diazonium salt, right? And how do you get phenol out of it? Tell me. Very simple. Diazonium has N2 group that will break apart. And how do you get the phenol? Yeah, yeah, that's in the last step. Take that H2O boiler, dilute H2SO4, heat it with dilute H2SO4. The OH group will come in and replace the N2 group. Okay. Is it clear? That's how you get. Yeah, we can use DAOs also. We can use diazonium also. All these we have done 4 methods. All 4 are very important. DAOs, cumene hydroperoxide, bisulfonation of benzene, benzene sulfonic acid, and by diazonium. Yeah, but if nothing is asked, you can use DAOs process also, right? So I hope this is clear. Okay, good. So this is all about the preparation of phenol. Now, what are the properties? Suppose phenol is there. So tell me, if you take any aliphatic alcohol and phenol, which one is more acidic? Which one is more acidic, the phenol or the ethanol? Aliphatic alcohol is less acidic. So phenols are slightly more acidic than water. Okay. Yeah, it is due to sp2 and it is due to resonance also. Yeah. Suppose if you take the H plus out of the phenol, I will write it like this. If you ionize the phenol, you get H plus. And this is the conjugate base of the phenol, which is known as phenoxide ion. And this is stabilized by resonance. Okay. Clear? So that's why it is slightly more acidic. So how will you prove the acidic nature of phenol? Tell me. So we know that it is slightly more acidic than water, but how can you show it? Can you tell me one reaction by which you can show that the phenol has acidic hydrogen? Yeah, tell me. Yeah, phenoxide. But what reagent you need to put? Yeah, you can react it with base. Okay. Is it clear, Darshan? So this is base, and base will take away H plus. So you have O minus Na plus. Okay, right. So phenol is soluble in NaOH. It reacts with NaOH because it forms a salt. So I hope this is clear. And this proves that the phenol has acidic hydrogen. Okay. The next thing is what is the acidic strength? Yeah, Darshan, tell me. Tell me what all chapters are coming in your school in the examination. Yeah, solution is also coming. Okay. Okay. Right. Good. So what is the acidic strength of these phenols that we can compare? Which is most acidic and which is okay? Alcohol, phenol, ether, aldehyde, ketone, carboxylic acid. Yeah. And biomolecules. Okay. Right. Mhm. Okay. So haloalkane and haloarine are actually very common type of reactions. So that already we have done many things in it. Okay. And aldehyde, ketone, and carboxylic acids, yeah, that also in biomolecules. Yeah. So tell me, acidic strength of phenol. This is also a common thing. What is the order of acidic strength of phenols? Nitrophenols and this. Yeah, Darshan. So if you have more and more NO2 group, the phenol O minus phenoxide ion is going to get stabilized because the nitro group is going to pull electrons. Okay. So the second one is going to be more acidic, and the third one has two nitro group. That is going to be, yeah, one. No, not one is the most. The fourth is the most. Okay, because it has three NO2 group. NO2 group will bring in positive charge. Okay, on the benzene, and here you can see that the positive charge, if it comes on oxygen OH, it is going to pull the electron more strongly, and so H plus will come out more easily. Okay, and if you have 2 NO2 group, that is going to be more acidic than the one which is having only one NO2 group. And if you are having three nitro group, that is going to be, in fact, The fourth one is so acidic that its name, its common name is also has the word acid in it. It is known as picric acid. Is it clear? Yeah. So what's the IUPAC name of picric acid? Tell me. Yeah. Yeah. 2,4,6 trinitrophenol. Good. And what is the chemical reactions which are given by phenol? We can react it with Br2. We can react it with neutral FeCl3. So these are the reactions of phenol, important reactions of phenol. Yeah, what do you get if you react them with one by one? You can tell me any reaction of phenol if it is not clear. Yeah, that's it. So what will happen if you react with bromine water? Yeah, Br will attach. Good. Where? Not to the OH. Actually, this OH is in resonance. Yeah, near to OH. And this phenol actually in water it changes to phenoxide ion. Okay, and the phenoxide ion is very resonance stabilized. So it is having minus charge on all the ortho and para positions. So this Br will get attached to all the positions where the ring is more electron dense, where the ring has more electron density. Is it clear? So what's the name of this compound is? It's a white PPT. Okay, and it's also a test for phenol. Okay. And how will you distinguish a normal alcohol and a phenol? Tell me. So this is the way, neutral FeCl3. Okay, it gives violet color with phenol. Okay, right? And this is a very famous reaction of phenol. These three are studied together. Yeah, Darshan, tell me quickly. This is acylation is different. Acylation is reaction with that is acylation. So acylation, the OH phenol has OH, the H and Cl are removed. Okay, and you have acetyl group. This is acylation of OH. Okay, this is something else. Okay, I will tell you the abbreviated name, RTR. Yes, Prima-Tiemann reaction. Okay, yeah. So this is not acylation. This is formylation. Okay, CHO group is known as formal group. And what's the name of the product? And what you get in this case and in this case? Yeah, these are similar to Riemann reaction, but slightly different. Yeah, salicyl aldehyde, and that is salicylic acid. These two are salicylic acid. Okay, because you took CCl4, so it is going to be COOH. Okay, and this one has a different name. Kolbe-Schmidt reaction. This salicylic acid, if I do the acetylation, by using CH3COCl or acetic anhydride, what you get? This is Kolbe-Schmidt. Okay, where you use CO2. So what you get, Darshan? If you do the acetylation of salicylic acid, this is salicylic acid. This one. Yeah, tell me. Remember it? This one. What's going to be the answer? Yeah, tell me. Colby reaction is no, Colby reaction is this one. I'm not asking Colby reaction. I'm asking if you do the acetylation of salicylic acid, this one, acetylation of salicylic acid, what you get? What you get, or I will write it here again. Uh, you have salicylic acid, and if you do the acetylation, what you get? Yeah, aspirin. Yes, correct. Okay. And how you do the nitration of phenol? Yeah, HNO3, dilute HNO3 you take. Suppose if you would have taken concentrated HNO3 or mixed acid HNO3 H2SO4, then you are going to get 3 NO2 groups. Okay, that is going to be picric acid. Okay, so if you want only one NO2, either ortho or para, so you are going to get, you need to take HNO3. Yeah, good. So, and what about ether? How do you prepare ether? Tell me. That also is coming in your exam, no? Yeah, good. So tell me, how do you prepare ether? Suppose I give you one ether. Suppose if you want to prepare CH3, CH, how do you prepare it? Yeah, Williamson ether synthesis. Good. So what you take? Dehydration of alcohol is different. Williamson ether synthesis, you take alkyl halide and you take alkoxide ion. Suppose you can think in this way. This is having O, right? So this is going to come and substitute the Cl. Okay, Williamson ether synthesis. So let me ask one question which is very famous everywhere. It is asked. You may be knowing it, and if you know it, we can move to the next concept. What is the appropriate method to prepare this ether? What's the IUPAC name of this ether? A common name is tertiary butyl methyl ether, because you have tertiary butyl group on the right hand side, methyl on the left hand side. So tertiary butyl methyl ether. So how do you prepare this ether? Used by Williamson ether synthesis. Should I take CS3Cl? The first method is this one. Now either you take this one or you need to take this one. Okay, I will write the option for you. And by which mechanism this Williamson ether synthesis proceeds? So which method is appropriate? And that will give you this Williamson ether synthesis. Tell me. Method 1 or method 2? Yeah, Darshan. The first method or the second method? And by which mechanism this reaction, what the mechanism of this reaction is? Yeah, tell me. This is SN2. Okay. Yeah, first method is correct. Okay. This one is correct, not the two. Because SN2 can take place on a smaller alkyl group. O minus can come in, the Cl will come out. Okay. So this can happen. But in this case, the SN2 cannot happen because this is very branched. Is it clear? So the SN2 does not take place on branch. Okay, so you don't have to take this. Suppose if you take this, SN2 will not happen, elimination will happen. You will not get the ether. You will not get the ether. Instead, you will get CS3OH. Okay, clear? So elimination will happen. So that you need to know. So this is making of ether. Another thing is breaking of ether. And how do you break ether? You react it with HI. HI 1 mole. What you are going to get here? Tell me. Yeah. Yeah, Darshan. What you are going to get in this case? Okay. Will you get? I will give you one hint. Are you going to get? Are you going to get break the ether in this way? In which means you get CH3OH, or you need to break the ether in this way. Okay, in which you put H on oxygen because you need to make OH, and you put I here. Which one will you get? Yeah, CH3I. Correct. Good. Right? And okay, this is the making and breaking of ethers. Now you can aldehyde ketone, a little bit idea you can give. How do you prepare aldehyde and ketones? Can you tell me? Okay, I will give you one question. You can do that. Yeah, yeah. You can also you can talk to. We can have extra classes also, no problem. Schedule. So morning you are having school. So when do you come from school? Yeah, okay, 3:30. In case suppose if you have some holiday, you can talk to the ma'am or sir, okay, and get some extra classes arranged. Okay, so we can have some extra classes also, no problem. Okay, so you can put your request to the system, and we can accordingly have some extra classes. Okay, suppose in the morning if you are free on some day, if you are not going to school. Yeah, yeah. Okay. Yeah. So yeah, whenever we have class, we can discuss, not a problem. So suppose if you have CS3, CN, okay. So I will tell you, I will not ask question. I will directly ask you to, I will directly explain it to you. Okay. Yeah. So what are the method to prepare aldehyde and ketone? Yeah, that is why, yeah. Okay. So it is, yeah, just go through your book, NCRT book. Okay. Let me show you the, yeah. So first is the naming. Okay. The basic naming you can go through that. Okay. Some common names are there like benzene, benzaldehyde, acetaldehyde. Okay. And this one. This is the IUPAC name. So for aldehyde, you need al. Okay, you need to put al. So ethanol, propanol, butanol, that you know, right? And for ketone, you need to put on. Is it clear? Okay. And this is yeah. Suppose this is the main functional group aldehyde. So if it is a main functional group, and suppose if the ketone, this is ketone, and this is aldehyde, but the main functional group is aldehyde. Okay, so you need to write as pentanol. Aldehyde is having more priority than ketone. So if ketone and aldehyde come together, the ketone is having less priority, and don't use the word on. You call them by oxo and you put it in prefixes before the name. If the functional group is of less priority, you put it in the before the name. Okay, so this is basic nomenclature. Let me know if you have any doubt in the next class also. We are having okay some basic nomenclature. I hope that you will be able to do it. Let me move directly to the reactions preparation. Okay. Yeah, preparation and reactions. Okay. So preparation is actually, how do you prepare by alcohol? Tell me quickly. You must have studied in alcohol. That portion is common to alcohol and aldehyde ketone chapter. I will explain it to you quickly. How do you get from alcohol, aldehyde and ketone from alcohol? From alkenes and from alcohols. From alkenes, it is very simple. You need to break the double bond, and for that you need to use ozonolysis. Lysis means breaking of double bond. Okay, so wherever you have double bond, that double bond breaks, and break the double bond and put oxygen atom on both the sides. Is it clear? Yeah. So ozonolysis, and but if you have a zinc or Me2S, CS3 whole twice S, just break the double bond, just cut the double bond and put OO, and that will give you the final answer. That's very easy. For example, if you have butanene, and if you do the ozonolysis, yeah, yeah, you can take the screenshot. I can send you, but yeah, you can take my number through the management, and they will actually I can share with you. Okay, or better, you can take the with the mobile. You can take the screenshot also. That will be easier for you. Okay. Aldehyde chapter. Yeah, very simple. Yeah, yeah. Okay. So ozonolysis, you know now. Butanene, what you are going to get? Aldehyde chapter. Yeah. Butanene is what? So break the double bond and you get this two aldehyde. Okay. And suppose so in your NCRT, so your school is also following NCRT. Which book they are following? Yeah, okay. So how do you get it from alcohol? Yeah, that you can tell me, because alcohol you must have studied little bit. If not, don't worry, I will explain you. So how do you get aldehyde from or ketone from alcohols? Yeah. So this is primary alcohol. Okay. So primary alcohol, you do the oxidation. Oxidation is removal of hydrogen. And how do you remove hydrogen? By heating it with copper, or you actually use PCC. PCC or copper, these are actually weak oxidizing agents. So they will oxidize primary alcohol to aldehyde. You remove one H from here, one H from here. Is it clear? So you get CH3, CH double bond. Okay. This is also CH3, CH double bond. But don't take, these are mild oxidizing agents. Suppose if you would have taken strong oxidizing agents, what will you get? What are strong oxidizing agent? Can you tell me, Darshan? Acidified potassium permanganate. That's very strong. So this aldehyde can get oxidized further. Okay. And you will end up with, so primary alcohol will get oxidized to carboxylic acid. Right? If you take strong oxidizing agent, strong oxidizing agents can be KMnO4H plus heat or K2Cr2O7H plus heat. Suppose if you take secondary alcohol, what you will get? Tell me quickly. If you do the oxidation of secondary alcohol, what you are going to get? Hmm. Oxidation of primary alcohol will give aldehyde by mild oxidizing agent, and oxidation of secondary alcohol will give you ketone. Darshan, is it clear? Suppose this is a secondary alcohol, and if you oxidize it, for secondary alcohol, you can take any. You can take either weak or strong. You will get ketone only. But for primary alcohol, you need to be very careful. For primary alcohol, if you want aldehyde, you need only weak oxidizing agent. Okay, clear? So this is one method, and so oxidation tertiary alcohol are not getting oxidized. So that is actually can be used. Okay. So preparation of aldehyde, ozonolysis of alkene, that I already discussed with you. Okay. Or by acid catalyzed hydration of alkynes. Alkynes actually, yeah, this is important. Alkynes, if you take, and if you add water, water to them in Markovnikov way. So H2NO. In Markovnikov fashion, you put H on the carbon atom where you have more hydrogens. So you get CH3, C double bond O, CH3. Okay. And Markovnikov addition is dilute H2SO4. HgSO4. Hg2 plus is a catalyst. That's the way to add water to alkyne in a Markovnikov way. In anti-Markovnikov fashion, if you want to add water, what you need to do? Yeah, Darshan, any idea? Yeah, peroxide, but you need hydroboration first of all. Peroxide with what? HBr peroxide is actually the anti-Markovnikov addition of HBr, but we are adding water. Okay, so that is by hydroboration and oxidation. For oxidation, you take NaOH and H2O. But don't say peroxide. Peroxide and what? Is it clear? Darshan, is it clear or not? So actually, okay. I'm going to add it in opposite way. H2 I'm going to put inside CH2 and COH. Okay, clear? So this is from alkynes, and by reduction, this is the partial reduction. Okay, partial reduction of acid chloride. Actually, what is there? Suppose if you take acid chloride, or the complete name is carboxylic acid chloride. So it is CH3COCl, or PHCOCl is benzoyl chloride. And if you do the addition, what happens is the addition is complete addition and you get alcohol. Okay. But if you want aldehyde only, listen very carefully. You don't want to reduce completely, you need to do only the reduction of Cl. So that is partial reduction. Okay. So you take H2, PD. Okay, that is the catalytic hydrogenation. H2 for hydrogenation, palladium is the catalyst. Normally you take H2PD, but actually this is catalytic hydrogenation is very reactive, so it will reduce it to alcohol. So you don't want complete reduction, you want just the reduction of Cl. So what you take poison also, so that the reduction doesn't happen in a complete manner, because that will give you alcohol. So you take some catalytic poison, BaSO4. That stops the reaction at aldehyde only. Suppose if you don't take BaSO4, you will end up with, if you take simply H2 palladium, you will end up with alcohol. But you want the reduction to stop at aldehyde, so you take barium sulfate, which act as a catalytic poison. We deactivate the catalyst. Okay, and the reduction stops at aldehyde stage only, and this method is known as Rosenman reduction. Is it clear? So this is Rosenman reduction, and there is preparation of from CN also. So this is partial reduction of nitrile, the CN group to aldehyde. You can just read it. We can discuss it on the next time, as today we are running out of time. So you can just go through it. This is from your NCERT book. I will explain you the details. and we can cover it by the next and we will complete it. Okay, so let me